In this video, I am going to discuss Bronsted Lowry acid-base theory. Arrhenius acid-base theory has some limitation. To overcome all those limitations, a new theory was proposed that is known as Bronsted Lowry acid-base theory. This theory was introduced by two scientists, Danish chemist Nicholas Bronsted and English chemist Thomas Martin Lowry. This theory is known as proton theory of acid and base. According to this theory, any compound that can donate a proton to other compound is called acid, and if the compound accepts the proton is called base. That means acid is a proton donor and base is a proton acceptor. According to Arrhenius acid-base theory, a acid molecule should donate H+ ions in aqueous medium and a base molecule should donate OH- ions in aqueous medium. According to Bronsted Lowry acid-base theory, acid is a proton donor but base is a proton acceptor. So that means presence of hydroxide ions is not mandatory to classify a molecule as a base. We can explain Bronsted Lowry acid-base theory using an example. This is a reaction between ammonia and water molecules. Here you can see ammonia molecule accept one hydrogen, means one proton from water molecule, and it converts into NH4+. So that means ammonia accept proton, the ammonia act as a base. Now water molecule donates H+, so water molecule acts as an acid. In Bronsted acid-base theory, we also have to understand the concept of conjugate acid and conjugate base. In this reaction, ammonia reacts with water. It gives NH4+ and OH- ion. Now ammonia accepts proton, so ammonia is base. Water donates proton, so it is acid. Now after accepting proton, ammonia converts into NH4+, so NH4+ is called conjugate acid of the base. Now after donating H+, H2 converts to OH-, so OH- is conjugate base of the acid. Let's take another example. Reaction between F- and water, it gives HF and OH- ions. Now F- accept proton, so F- is base. Water donates proton, so water is acid. Now after accepting proton, F- convert to HF. So HF is a conjugate acid of the base. Now after donating proton, H2 convert to OH-. So OH- is the conjugate base of the acid. When an acidic substance loses a proton, it forms a base. So that is called conjugate base of an acid. Similarly, when a basic substance gains a proton, it forms an acid. So it is called conjugate acid of a base. Bronsted Lowry acid-base theory has some advantage over Arrhenius acid-base theory, but at the same time it also supports Arrhenius acid-base theory. We can explain this statement with an example. According to Arrhenius acid-base theory, acid should dissolve in water and it gives H3O+ ions. So that's why sulfuric acid is considered as Arrhenius acid. Now if we explain this reaction using Bronsted Lowry acid-base theory, we can see that sulfuric acid behaving as an acid because it donates H plus and H2 accepts H plus, so that's why H2SO4 is an acid and H2O, which accepts H plus, it acts as a base. So after accepting H plus, H2 convert to H3O plus. So H3O plus is a conjugate acid of the base. And after donating H plus, H2SO4 convert to HSO4 minus. So HSO4 minus is a conjugate base of acid. There are few compounds which can act as acid or a base depending on reaction condition. These kind of molecules are called amphoteric molecules. Now water is one of such molecule which can act as acid or base. In the first reaction where ammonia reacts with water, water acts as acid because water donates proton to ammonia. Now in the second reaction between water and hydrochloric acid, H2O accepts proton from hydrochloric acid, so H2 acts as a base. There are few limitations of Bronsted Lowry acid-base theory. There are few compounds like aluminum chloride, ferric chloride, boron trifluoride. They are acidic in nature, but they don't have proton. So Bronsted Lowry acid-base theory is unable to explain their acidic nature. Similarly, this theory is also unable to explain the reaction between acid oxide and basic oxide because there is no proton transfer is taking place. Here we have taken one example. When calcium hydroxide reacts with H2SO3, we are getting calcium sulfite and water. So it is an acid-base reaction. But when sulfur dioxide and calcium oxide, sulfur dioxide is acidic oxide and calcium oxide is basic oxide. When they react, they are also giving the same compound calcium sulfide, like this reaction. But is this reaction is an acid-base reaction? Because here no proton transfer is taking place. So Bronsted Lowry theory is unable to explain this reaction. To solve all this limitation, again a new theory was proposed, which is known as Lewis acid-base theory. So there are three theories which explain the concept of acid and base. The first theory which was proposed, that is Arrhenius theory. Arrhenius theory is applicable only for limited number of molecules which can dissolve in water, and if it gives H plus, it is acid. If it gives OH minus, it is called base. Now Bronsted Lowry theory is one step further than the Arrhenius theory. It is called proton theory. When a molecule donates H plus, it's called acid. When a molecule accepts H plus, it's called base. So no more OH minus is needed to classify a molecule as a base. And Bronsted Lowry theory can be explained in both aqueous and non-aqueous medium. But still we have seen there are some limitations. So now Lewis acid-base theory was proposed. It is the modern theory to explain the acidic and basic nature of the molecules because it decides acid and basic properties based on electron donation or electron acceptance. So next video I am going to discuss about Lewis acid-base theories. If you think this video is useful for your study, then subscribe my channel Chemistry Affinity and share it. If you have any questions related to chemistry, you can send me a mail chemistry.affinity@gmail.com. Thank you for watching this video.